Okay, so a directed acyclic graph is very useful. It's kind of you use dots or nodes to illustrate variables, and you draw arrows that have a direction between them to kind of illustrate um, this variable. We think it has a causal effect on another variable. Um, One thing that is often, I think, mistaken is that drawing an arrow is kind of like the assumption you're making, but it's actually the other way around. It's when you don't draw an arrow, it's a very strong assumption. You're assuming that there is no effect at all, that the effect is zero. So when you're drawing DAGs, in doubt, draw an arrow. Okay, so for example, this is a famous example that I talk about in my book, right? So smoking has a causal effect on lung cancer. There was a huge debate in the 50s and 60s around this. And very famously, I posted about this a lot, but Fisher argued, well, we know that genetic factors influence the development of cancer. And he argued, why wouldn't genetics also influence the propensity for people to smoke? And this third hidden genetic factor could be the one responsible for the correlation we observe between smoking and lung cancer. And it's not because smoking has a direct effect on lung cancer. So with DAGs, we kind of make all of this very visual, very intuitive. Other strengths of DAGs, they don't assume any form for the link between two variables. So for example, smoking and lung cancer, on this DAG, we just say there is a causal effect by putting an arrow, but we don't assume that it's linear or quadratic or any form. So in this sense, we say that it is fully non-parametric. Another strength of DAGs is that we can use a lot of the mathematical tools to do causal inference with a given DAG are fully automated. They can be implemented by algorithms. So, for example, with the ggDAG package I was talking about earlier, you can draw a DAG and use R to ask it questions like, oh, what are the confounders? What confounder should I control for? Is the causal effect identifiable from my data? Right? Which means, can I estimate it consistently from the data I have? And consistently is a technical term. I won't get into that, but all of this is to say that it kind of automates away a lot of the work when you have a DAG that you're confident with. So this is powerful, but it's also a double-edged sword, right? Anytime we automate a lot of the work of inference and the work of conducting scientific inquiry, we're a bit susceptible to not thinking deeply enough. So my advice is that drawing the DAG is shouldn't not be taken lightly, especially when you have a lot of variables in a complex case. It's extremely important that you are confident that the DAG is accurate as best as you can. So that might involve speaking with experts, right? So as a statistician, I don't always know everything about the field. I need to speak with experts to kind of draw a cool DAG before jumping to, oh, let's ask the computer to solve this problem for me, right? So it's important to have a DAG that's based on expert knowledge rather than data-driven, except when you're doing causal discovery, which we will explain a bit later. So this is kind of a short introduction to DAGs, and I just wanted to show maybe another one, just because, yeah, I think it's interesting. So this is another example. So this one is not any specific case, but here the W is like our treatment variable, the Y is the outcome, and then we have three variables that are related like this, and this DAG is is a very famous one because it's called M bias, and there was a huge debate in the literature between Rubin, Pearl, and others about what does this DAG mean for causal inference. So I won't go into the details, but I will cover this in the book. If you have questions, you don't need to wait for the book. Just ask me. But it just shows that we can kind of make them complicated. Someone could argue, well, why is there no arrow from Z1 to Y? And then you kind of have to justify that based on domain knowledge, because the absence of arrow is a very strong assumption. So just to show you, you can add variables, you can have very complex DAGs, and these are very useful for causal inference.